There have been many Spider-Man animated series released over the years, and usually, when you ask a fan which one they like the most, they will probably say either the 1990s animated series or the Spectacular Spider-Man, which was released in 2008. I have to admit that I am a little biased because I grew up watching reruns of the 1990 series. I mean, Christopher Daniel Barnes's version of Spider-Man almost became an icon in my household, and his voice was almost like music to my ears.
Surprise, shocker!
And every time that opening theme played, there was no way anyone could resist wanting to become Spider-Man, shoot webs, and swing through the amazing streets of New York City. That's crazy, but still amazing, I guess. In the world of Spider-Man, webbing is not simply a tool for moving around. It can hold people, pull heavy objects, tie up enemies, and even help Peter Parker save people in dangerous situations. That made me curious about something we often overlook whenever we watch Spider-Man. Just how different is natural spider silk from artificial spider silk? Before answering that question, I want to show you a picture. This beautiful golden cape is the largest piece of fabric ever made from natural spider silk. It was woven from the silk of 1.2 million golden orb weaver spiders in Madagascar over a period of 3 years, with a team of 100 people. It really takes an incredible amount of work to make fabric from natural spider silk, because this material seems almost magical, and humans have been fascinated by it for thousands of years. In ancient times, the Greeks already knew how to use spider silk to stop bleeding. Even today, fishermen have used spider silk to catch fish. When small insects crash into a spider web, the silk usually does not simply break. This is the result of millions of years of evolution, and when compared by weight, spider silk can be stronger than nylon and even steel. On top of that, it is also environmentally friendly. That's pretty cool. These extraordinary properties have attracted the attention of geneticists, biochemists, and material scientists, all trying to unlock the secrets of this incredible material. For spiders, producing silk is simply one part of their biology. The earliest ancestors of spiders appeared around 380 million years ago during the Devonian period, among some of the first animals to live on land. At that time, they already had narrow waists, segmented abdomens like modern spiders, and silk-producing glands. The only difference was that these glands were located in the middle of the abdomen instead of at the end, like they are today. This suggests that the earliest spiders did not build webs. Instead, they used silk and sheets to cover their eggs or line their burrows. Then, hundreds of millions of years later, spiders with silk-producing glands at the end of their abdomens appeared, opening the way for much more advanced types of silk and complex web structures. Of the more than 45,000 spider species that exist today, around 12,500 are orb-weaving spiders. They are like architects, creating spiral-shaped webs between trees and plants and forests and other areas with vegetation. Inside the spider's body, the process of producing silk quietly begins. The silk starts out as a liquid. As the silk solution moves through a narrow passage toward the spinning openings, the combination of removing water, changes in acidity, and tension gradually turns it into a solid material. Finally, the silk passes through the spinning glands and is pulled into a complete strand that is light, pure, and incredibly strong. There are at least 7 different types of spider silk. Each silk gland in a spider's body has its own specific role. Major ampullate silk creates the main bridge lines and radial threads of the web. The flagelliform gland produces the soft and flexible spiral part, while aggregate silk forms sticky droplets that hold the prey tightly as soon as it gets trapped. But among all these different types of silk, the one that fascinates scientists the most is dragline silk, the spider's lifeline. Scientists discovered that this type of silk allows spiders to hang from ceilings, move freely across their webs, and quickly drop down when they sense danger. Dragline silk is one of the most impressive natural materials ever discovered, and it is often compared to steel. So, is this comparison actually exaggerated? When we look more closely, we have to understand that strength is not just one single measurement. Different materials react very differently to different types of stress. Here, we will only talk about the ability of spider silk to resist breaking when it is stretched. Even though it is a thin and delicate biological material, spider silk can have a tensile strength comparable to, and sometimes even higher than steel. To put that into perspective, the spider web that Spider-Man shoots would not be able to withstand the cuts of the Green Goblin, but it could help him pull objects weighing hundreds of tons, such as a moving train, or even hold a helicopter in the air. In Spider-Man movies, Peter Parker often creates web fluid using equipment available in his laboratory, and then keeps bottles of the liquid web hidden in his backpack or somewhere else. It looks easy in movies, but in reality, creating spider silk is extremely difficult. In the past, scientists tried to create spider silk through biotechnology. They tried genetically modifying host organisms so that they could produce spider silk proteins. But then a major problem appeared. To create strong silk, the protein itself needs to be large enough. The tensile strength and toughness of spider silk are closely related to its molecular weight. The larger the molecule, the stronger the silk can be. Scientists tried using different organisms and protein-producing systems, including plants, goat milk, silkworms, and E. coli bacteria, but they all failed to fully reproduce the physical and biological properties of natural spider silk. A major breakthrough came in 2018 when scientists added a short genetic sequence to the DNA that helped trigger a chemical reaction. This allowed newly produced proteins to link together and combine into much larger proteins. The results surprised even the scientists who created it. The resulting protein reached 556 kilodalton, which was even larger than most natural spider silk proteins. These giant proteins could then be spun into fibers with properties very close to real spider silk. However, scientists still have not developed a standard process for mass-producing spider silk like Oscorp does in The Amazing Spider-Man. Considering all the difficulties we have seen, it is not hard to realize that the artificial webbing Peter Parker creates cannot match natural spider silk like the one used by Tobey Maguire's Spider-Man. I will use a few movie scenes to compare them. In No Way Home, when Peter 2 and Peter 3 meet, they have a small fight using their web shooters. The result shows that Peter 2's natural webbing can be fired faster and more powerfully than Peter 3's mechanical web shooter. In Brand New Day, Peter 1 can only defeat the military's weapons by using natural webbing because it can be produced continuously and is stronger, faster, and tougher than artificial webbing. In Marvel's Spider-Man, there is a scene where Peter Parker uses natural spider silk to stop a train, similar to what happens in Spider-Man 2. However, the webbing breaks after only a few seconds. This further shows that natural spider silk is superior to artificial spider silk. With all the difficulties involved in creating artificial spider silk, why don't we simply raise a huge number of spiders and let them produce natural silk? Spiders are solitary animals, and they can even eat each other when kept together. And as I mentioned earlier, producing a single piece of fabric like that cape took 3 years, so the production rate would be extremely low unless humans find a way to mass-produce spider silk artificially, or use spider silk only as one of several materials, such as in modern bulletproof clothing. So far, humans have not been able to produce enough spider silk to manufacture it on a large scale, but with recent advances, it is possible that spider silk could eventually become a replacement for petroleum-based synthetic fibers in many industries. If this trend continues, spider silk could potentially play a role similar to carbon fiber in the future. And when that happens, these studies will remind us of something simple. Innovation often begins by observing nature. By looking closely at the solutions that nature has developed through millions of years of evolution, we can understand that the answers to many difficult problems may have been around us all along. Spiders may not be the easiest animals to like, but they are truly the genius engineers of the wild. They are a wonder of nature that inspires modern engineers to recreate their incredible abilities in human life. That's everything I know about spider silk. What do you think? Let me know your opinion, and don't forget to like and subscribe so you don't miss more interesting Spider-Man videos.
After so many times saying it, thank you seems soft.